The prefrontal cortex is the brain's executive chamber, the region where raw information is transformed into judgment. When evidence enters the cognitive system, sensory data alone does not determine belief. Instead, the prefrontal cortex integrates multiple streams: memory retrieved from the hippocampus, emotional signals from the amygdala, and predictive models already stored in neural networks. Evidence evaluation therefore becomes a negotiation between incoming data and existing mental architecture. The more developed the prefrontal cortex's regulatory capacity, the more capable the mind becomes at suspending immediate conclusions and testing competing interpretations. Scientific thinking emerges precisely here. It is not simply intelligence. It is the disciplined ability of the frontal cortex to slow cognition down, examine evidence under uncertainty, and prioritize verification. Evidence rarely arrives in a neutral brain. Long before analytical reasoning activates, emotional circuitry has already interpreted the situation. Signals from the amygdala move rapidly, tagging information with urgency, threat, or reward. The prefrontal cortex must then intervene, inhibiting impulsive conclusions and reevaluating whether emotional certainty aligns with empirical reality. This conflict defines the neural battleground between myth and science. Emotional pathways favor speed, coherence, and survival relevance. Prefrontal reasoning favors accuracy, skepticism, and delayed judgment. When the executive cortex is overwhelmed by emotional intensity or cognitive overload, reasoning collapses and belief defaults to intuition. The capacity for scientific evaluation therefore depends not merely on knowledge, but on the strength of executive inhibition, the brain's ability to hold. Within the prefrontal cortex lies a distributed executive control network responsible for managing complex reasoning. This network coordinates attention, working memory, and decision thresholds, allowing the brain to compare hypotheses rather than accept the first plausible explanation. When evaluating evidence, neurons in the dorsolateral prefrontal cortex maintain competing possibilities in working memory, while anterior cingulate systems monitor conflict between interpretations. This dynamic interaction allows the brain to detect logical inconsistencies and refine judgments over time. Scientific reasoning is therefore not a single act of insight, but a sustained neural process of model comparison. The stronger and more flexible this executive network becomes, the more capable the brain is of resisting cognitive shortcuts and constructing explanations grounded in evidence. The brain encounters far more information than it can consciously process. The prefrontal cortex therefore functions as an evidence filtering system, determining which signals deserve cognitive resources. Through selective attention and inhibitory control, irrelevant inputs are suppressed, while relevant data is amplified for analysis. However, this filtering process is not perfectly objective. Existing beliefs shape what the prefrontal cortex allows into conscious evaluation. If incoming evidence threatens an established framework, the brain may unconsciously downgrade its importance. This is why highly intelligent individuals can still overlook critical facts. Evidence evaluation depends not only on cognitive capacity, but also on the flexibility of mental frameworks. True intellectual rigor emerges when the executive brain learns to question its own filters. Scientific thinking represents one of the most demanding cognitive operations the brain can perform. It requires the prefrontal cortex to construct abstract models, test predictions, evaluate contradictory evidence, and revise conclusions when data changes. Unlike intuitive reasoning, which seeks coherence and closure, scientific reasoning tolerates uncertainty and welcomes falsification. This capacity emerges from coordinated activity across multiple prefrontal regions responsible for logic, probability estimation, and metacognition. In essence, the brain must temporarily override its natural preference for stable narratives in order to pursue empirical truth. The prefrontal cortex becomes the architect of intellectual humility, the neural system that allows humans not only to believe, but also to reconsider what they believe when evidence demands it.